In this video, we'll look at number 5. We're comparing some different accounts. So Mr. and Mrs. Dunphy have open savings accounts for each of their 3 children. Each account has a principal of $3,500. Haley has an account earning 1.75% annual interest compounded quarterly. Alex has an account with 1.5% interest continuously. Luke has an account earning 1% interest compounded semi-annually. So write an equation that represents the value of each child's account. So Haley starts with the $3,500. The account has 1.75% interest compounded quarterly. So our compound interest formula would be 1 plus R, in this case, is 0.0175. N quarterly is 4 times per year. And then the exponent NT, so 4 times, and it's for however long has passed. So we'll just call that T for time. Alex also starts with $3,500. Her account earns 1.5% interest continuously, so we're using PE to the RT in this case. So principal is $3,500, E to the interest is 0.015, and then T. Luke also starts with $3,500. That account earns 1% interest semi-annually. So 1 plus R over semi-annual is 2 times a year. And then NT, so 2 times a year for T number of years. Each child will be allowed to access their savings on their 21st birthday, whose account will have the most value at that time. So Haley is currently age 18. So 21st birthday for her is 3 years later. So I would evaluate her account at a time of 3 years. So you can type all of this into your calculator at once if you are careful about the way you're typing it in. If you evaluate this part first, 0.0175 divided by 4, you can take this as your R over N value, but make sure you don't round it. So if you don't want to worry about all of those intermediate numbers, when typing it in all at once, make sure you're telling your calculator where the parentheses should be. So 1 plus this fraction, close parentheses, to the exponent of 4 times 3, which is 12. So she will end up with $3,688.24. All right, Alex is currently 15, so 21st birthday for her will be 6 years later. So her account is $3,500 E to the 0.015 times 6 years. Which will give her $3,829.61. And then lastly, Luke is currently 13. 21st birthday for him is 8 years later, so using his account's formula, he'll be 21 in 8 years, so 2 times 8. 3,500, 1 plus parentheses 0.01 divided by 2 to the 16th power. Okay, so whose account will have the most value at that time? We can see here that Alex will have the most money. Let's also look at Number 6 and 7, and actually these two I'll go ahead and do in a separate video. The keyword on these is depreciated, declining. So refer to the next video for number 6 and 7.